So technically you could be able to make these connections, but I definitely want to talk about them instead. A simple random sample is conducted on a sample of particular species of lizards, resulting in a 95% confidence interval of 3.13 inches to 5.27 inches. So this is an interval. And we want to conduct a test, but all we have is a confidence interval. So let's draw what this would look like to us right now. So I've got a curve because I'm dealing with normality. How many lines do I have drawn if it is a confidence interval? 2. I have one on each side. This one is at 3.13 inches. This one is at 5.27 inches. So this is saying we are 95% confident that it is between 3.13 and 5.27. And we are conducting a hypothesis test claiming that the mu actually is 4 inches. So if we have a picture that looks like this, now applying to chapter 9, where we are right now, what is the only alternative hypothesis that looks like this? So we're dealing with this one, so we're still dealing with mu, we're still dealing with 4 inches. The only one that would result in a picture that looks like this is not equal to. It is 2 tails. So this relationship that we are making right now is only between a confidence interval and a 2 tail. So alpha, if I were to shade these, alpha is the total shaded area. So if this is a 95% confidence interval, how much is here? So how much is not here? How much is here? So how much is not here? 5%. So what is alpha? And I'm going to write in parentheses total shaded area. Above. So in that picture is the total shaded area. Usually we know total shaded area as p-value. Alright, so we are testing this. So if I wanted to draw that on that picture, where would this line be? Somewhere around here. So where did my claimed value fall? In the interval. So what does that mean about being able to reject it? Does that seem reasonable if it fell within where we said it would? Yes. So that was actually one of the questions on your last test, but we didn't know the chapter 9 perspective of things. We just knew that it did fall within, so we couldn't go against it. So now we're making the connection. We can call this shaded part, our rejection region. Which means if it falls there, we reject it. But let's answer a chapter 9 conclude just based off of this green line with this blue picture. I conclude from chapter 9, I have two options here. What are they? So if it fell where I thought it would, what would be the reasonable answer to put there? What are we failing to reject?
The null hypothesis.
Which is?
mu equals 4 inches.
So usually we would write what here?
Since the p-value is not less than.
Did we ever write a p-value?
No.
So instead, how did we come up with that conclusion?
U is also in the 95% confidence interval.
Since the claimed mu value falls within our 95% confidence interval, so because all I had to go off of was an interval instead of a p-value, that's what I'm plugging in there. What's my second sentence start with? We do or do not. So if we fail to reject, that means we
Do not.
and what is it that we do not have enough convincing evidence to say?
The alternate.
So that was the only part that was different. We didn't have a p-value, so we couldn't say the p-value was something. But we made our decision based off of it fell in the confidence interval, and that's fine. So if this did not fall in the confidence interval, then that would switch this to be reject, and that would switch this to be we do. Questions on that? That is continuing that problem from the test I just gave you, but it's answering it from the chapter 9 perspective instead of only from the chapter 8 perspective. We just couldn't write it as a conclusion because we didn't know that was something. Alright, now, that's definitely something that can happen. That's something that you should have been able to pretty much think through because we did it in chapter 8, except just writing the conclusion. This next section is a different way to get to your conclusion, but not because you're given different information. So like when I used to teach CP a long time ago, not when I taught it here, the textbook taught it this way. So typically we come to our conclusion by comparing the what from our sample. We just said usually what goes here? P-value. We usually compare the p-value from our sample to the what for the problem? But instead we can think about how we got each one of those. So our p-value, when I am working through a problem, what is the last thing, what do I use to find my p-value? You probably have what line? It's the shading from the line, but that line is my what? Look at a problem like right in front of you and you'll look at it and think about it. Test statistic. And we can relate our alpha you don't need to draw this. If it's a one tail and that is an alpha of 0.05, chapters ago, I could find what this line is. What did I call that? actually get to our conclusion by comparing our test statistic to our critical value instead of our p-value to our alpha. So we're testing to see if this new expensive machine makes a higher percentage of its products with flaws than the old machine. What's important out of that sentence? And I'm dealing with proportions. Really all I wanted you to get out of that is the fact that we're shading to the right. Since the parameter of interest in this problem, if we're doing percentages, is what parameter? Then we would use a what for our critical value? Alright, so let's draw the curve that goes with this. We decided that it was higher, so it would be greater than, which means we're shading to the right. And I am telling you that alpha is 0.05. So I can find what this critical value is to go with that alpha. So thinking through, there are different ways to do this. How can I find what that critical value line is? I can look at the blue sheet because it says tail probability. I can look at the yellow sheet and find what number? To point what? And yes, that's fine, but really I'd be looking up 0.95. Or the inverse function, which some of you use that and some of you don't. And I end up getting a critical value of what? So everybody look at your blue sheet with me. Just making sure that we understand kind of the process of where this is coming from, if you didn't figure that out along the way. This goes back to chapters before. If I say find the area of the shaded, and you find the line for that, we've done this a lot. But now that I have the blue in front of me, on top I have options of tail probability. So 0.05 tail probability is one of my options. Where would I be looking for a z? All the way down the bottom, infinity, and what does it say? So if you were lost with how I got this, that's one way that I could have gotten this. Questions right now? So I'm just going into this question from a different perspective. So I've got my critical value, which is 1.645. And then I'm going to give you the whole scenario. This is all from our sample data, and we're going to find the test statistic. So our old machine was 92% effective, so that's my what? P naught, that's my claim. We test a simple random sample. Well, that's helpful. 200 is my what? And 192 of them are made without flaws, so that's my number of successes. So I'm using my n and my number of successes to get my what? So p hat is 192 over 200, which gives me so general equation, my test statistic would be what? P hat minus P naught divided by so plugging in my numbers, P hat is what? 0.96 minus 0.92 divided by square root of 0.92 times 0.08 over and what do we get? And just for the sake of, because it's like a Z, 2.09. Everybody with me? So I can, instead of going to a p-value, I can directly compare this to what I've already done. So this is telling me an alpha of 0.05 means I am cutting off where I would reject or not reject at 1.645. So where does this fall? So this falls here. And we said this shaded part is called the what? Rejection region. So it falls within the rejection region, which means we are going to reject. Where you would see a problem like this, it might give you where does your test statistic fall within these critical values, and you could answer it directly like that, or you could convert them all to p-values and still do it as p-value versus alpha, and that's fine. But I wanted you to see this perspective of things. So our conclusion here would be that we what? What is it that we're rejecting? Which would be, we didn't write it, but equals what? 0.92. Now it would be since our test statistic falls in the rejection region, this is actually the reason for it being called a critical value, because it's a critical value to which it's rejected or it's not rejected. And then we would finish that just like we always do with, we what? At what? We didn't write it, but we know we talked about it.
P is greater than 0.92.
So we've just talked about today 2 different ways to get to the same conclusion, but not directly through relating p-value to alpha as we always have.